Assalamu alaikum. Greetings from Team Absolute Zero. Welcome to the presentation that we have created for this course. The topic of this presentation is about the line following algorithm. But before jumping into the main item, let me introduce the magicians who worked so hard to make it all possible.
Assalamu alaikum. My name is Saiful Hassan and my ID is 19315135007.
Hello everyone, my name is Shantanaha. My ID is 19315133385.
Assalamualaikum. My name is Janaban Junaid and my ID is 19015134441.
This is Tanvir Ahmed, bearing ID 19315135001.
Hello, this is Bijay Bishash. The ID is 193151346.
And I am Mahmoud Ibn Zaman, ID 19315134118.
Here we can get a glimpse of what will be discussed in this presentation. So without any further ado, let's begin. To make the introduction, we have all the basic knowledge of what a robot might be. It is basically any tool or machine which has the ability to carry out any intended jobs by the creator. The machine works in an automated way, and this can be programmed especially using a computer device. Among various types of robots that we have seen at different times of our lives, here is a type of robot that we are going to talk about here. It is a robot that goes by the name line following robot, also known as LFR. What makes it category of robot, you ask? Well, it is a type of machine that has the ability to detect a certain line on the path and following it. The line can be of certain types, especially a black or dark color, placed on a very bright surface, or even it can be invisible, much like a magnetic field. In this slide, we can see the maneuvering function of a simple LFR. The LFR runs while sensing a particular line placed on its path and use its light-sensitive sensors to be on its course, and also continuously correcting wrong moves by a feedback mechanism. Here are the basic components needed to build a basic line following robot. Many of the components are known thanks to the courses like Basic Electronics and Digital Electronics. Since the LFR needs a microcontroller device installed in its chassis, a unit called Arduino Uno has been used. What it does is control the components installed on the LFR chassis according to the data extracted from the sensory components, which are handled using algorithms present in the given code. Other types of microcontroller units like Raspberry Pi can also be used as an alternative, with minor changes in the architecture of the LFR. For sensor equipment, a 5-IR sensor has been used. This has been chosen over other IR sensors is because it provides more precise detection thanks to the phototransistors and its structural weight. As moving parts, gear motors have been used as an actuator. This will accelerate the LFR to move according to the intended command received from the motor driver unit that derived from the Arduino Uno. As previously discussed, a motor driver has been used in this LFR. To be more precise, the L298 and motor driver has been used over other motor drivers available. It is a module for controlling the motors, and it has the ability to control up to 4 DC motors. Since this LFR features 2 DC motors, this motor driver was an optimal choice. In this slide, the working principle of the LFR from the POV of the IR sensor has been discussed. Since a 5-area IR sensor has been used, in the figure, we can see 5 sensory modules present. If the third sensor detects a black color, it will send signals to the Arduino Uno unit to keep steady and move forward. And as soon as the robot starts to go off chart, the sensor will send similar signals, only this time to go left or right, depending on what sensor detects, and black color on the surface. This is the logic table that the motor driver uses. According to the data provided by the sensors, it is seen that the robot will stay functional only when the sensors receive at least 1 0 values present, and will cease to function any longer as soon as all values become 1. Here is a two-dimensional view of the chassis or the board the LFR uses that was created as a project. The design has been done using software like Fusion 360 and Blender. This model has been 3D printed and used as the main board of the chassis of the LFR. And here is a rough model view of the prototype with all the components present. This slide demonstrates the diagram of the circuit design used in this LFR. The design has been done on an online design tool called Tinkercad. A huge prop to Mahmoud Ibn Zaman for configuring the 5-area IR sensor manually. Now here is the code written in C++ used in the microcontroller unit present in the LFR. This contains the necessary values and algorithms working in the LFR while functioning. And lastly,
Here we can see how our team members have assembled all the components according to the circuit diagram shown on previous slide. After assembling, we have presented our LFR in a competition held on Daffodil International University Robotics Lab.
Here is the real life view of the final outcome of the project codenamed Snakebite, a product of Team Absolute Zero. With this being said, we have reached the end of our presentation. I would like to thank you for staying with us throughout the whole demonstration.